Each variable has a type, name, and value. They also have an address, which is where the variable is located in computer memory. The ampersand is the address of operator and shows the memory address. Let's create a new console application and explore this feature. In the main function, we'll create the variable a, use printf to output its value and its address, &a. A pointer is a special variable that can hold the address of another variable. The variable it points to can be accessed by using the asterisk, or value@, operator. To be clear, if you have a pointer p that points to some variable a, asterisk p means the same thing as a, and ampersand a means the same thing as p. To declare a new pointer, we write the data type of the variable it is pointing to, followed by an asterisk, and then the name. As the pointer itself is a variable, the address it contains can also be changed. Pointers have two main purposes: exchanging data with functions and dynamic memory allocation. We'll talk about the latter use in the next video. Let's say we have a function called double. Double multiplies any integer by 2. As it stands, if we call this function from main and pass a variable to it, the variable will not change. This is because the function is not working with the original variable. It's working with a local variable that has been initialized with the same value as the original variable. It is this local variable that's doubled, and when the function ends, the value is lost. So instead, we'll pass the address of the original variable into the function. Then we'll refer to the variable at the pointer's target, which will allow us to alter it directly. No local copy of a will be created. Remember to change the data type in the function declaration from int to int asterisk. That makes it a pointer to an integer variable. So far, this might seem a bit pointless, given that we have used return in the past to send data back to the function that gave the call. Unfortunately, there are limitations to relying on returning data. For one, we can only return a single value. We can't return arrays or structures. With pointers, though, we can get around this. To demonstrate this problem, let's look at a new function, swap, which takes two values, x and y, and swaps them around. Because we can only return one value, creating local variables won't be of much use, because we need to send two back. However, with pointers, we can take the addresses of these variables and manipulate the values of x and y directly. We still need to create a local variable called temp to perform the swap, but since we aren't holding on to any of its data, there won't be any problems. The values we need will end up back in their original variables. These two methods of passing parameters are called passing by value and passing by reference. When passing by value, the parameter is just a regular variable. What we pass is the value which will be used to initialize a local variable in that called function. Nothing we do to this parameter will affect the variable that has been passed. It takes more time and memory to pass by value because we need to copy the data around. But it is more secure because the function won't be able to damage the original data by mistake. When passing by reference, the parameter is a pointer, so what we need to pass into the function is the address of the variable, not the variable itself. Any changes made to the pointer's target will affect the original data. It's more efficient than passing by value, but there's a higher risk of messing up your data. To use an analogy, passing by value is like giving a classmate a copy of a group project on a USB drive. Now there are two versions of it. Altering one will not affect the other. Passing by reference is like giving them a link to Dropbox or Google Drive, where you can both alter the same project. Well, that's it for this part of Module 2 and an introduction to pointers.